Hi, welcome to my video on surface area. This is practice 1, part B. Again, they're just a review of the surface area. Number 1, find the surface area of a right cylinder with a height of 40 millimeters. Circumference of the base is 12.56 centimeters. And we're going to find the surface area to the nearest tenth of a square centimeter. Well, we have the surface area of a right cylinder, so let's take the right cylinder to be this shape. Here's the right cylinder. I always like to draw a diagram of what I'm doing. And that's the right cylinder. This has a height of 40 millimeters, so that's equivalent. Millimeters to centimeters, we got centimeters and millimeters, so let's convert to square centimeters or convert to centimeters. So 40 millimeters, that's small units going to large, so we got to divide by 10, so it's 4 centimeters. Now, what we have, we want to get the surface area, and the surface area is, let's see, the surface area of a cylinder is, we have a circle as a base, and we have a circle here as the top. So we got 2 bases, plus we have a lateral area. So the 2 bases are 2, the base is a circle right here, so it's 2 pi r squared. And the lateral area, well, let me use this diagram here. Right here, I have a cylinder. You can't see it, but I'll turn it sideways for you. So this is the cylinder. I marked the bottom with black for some reason. I'll show you. So if you take the cylinder and unfold it, like I put a piece of tape on it. If I unfold the cylinder, what I have is this. So to unfold the cylinder, in other words, cut the cylinder down from top to bottom at a right angle, I have a rectangle. And let me explain that. Here I go back to the original diagram. Now, so if I unfold, if I cut the cylinder down through here, then what I have is this shape. So the black I had was right here, and the reason I did that because I wanted to put this, that's that distance there. So this bottom part is the circumference of the circle, and this part here is the height. So the lateral area is circumference times height, and the circumference of a circle is 2 pi r times the height. So the lateral area is the circumference, which is 2 pi r times the height. So after all that's done, I need to find the radius. I have the height, which is 4, but I don't have the radius. So let's continue. So the circumference is 2 pi r, and the circumference is 12.56. 2 pi is 3.14. So that gives 12.56, 6.28 r. So if I divide by 6.28, that goes into 12.56 2 times. So the radius is 2. Now I have all the info to solve this. So pi is 3.14. The radius is 2. And we have 3.14. The radius is 2. And the height is 4. So if we multiply that out, 2 times 3.14 times, 2 squared. So 2 squared is 8. 8 times 3.14 is 25.12 if you use your calculator. And right here, I have 2 times 2 times 4, 16. 16 times 3.14 is 50.24. Or we can almost say it's double this because there's an extra 2 here when you multiply. And add that up, I get 75.36. And that's square centimeters. And it says rounded to the nearest square centimeter. So to the double stroke wave like this means approximate. I think in one of the other videos I did it as a single, and a single stroke wave means similarity. So to the nearest tenth, 75.4 square centimeters. This was this trick of cutting the cylinder down to the side from perpendicular from top to bottom, lays it out as a rectangle. And that's how I remember. Number 2, find the surface area of a cone whose height is 9 meters. The slant height is 1,500 centimeters, and we want to find the nearest square meter. Well, we got meters and meters. We got meters, and this is centimeters. So this, there's 100 centimeters in a meter, so you divide. So the slant height is, divided by 100, is 15 meters. So let's draw that diagram to see what we have. We have a cone, and this is the bottom of the cone. So it says it has a slant height. The slant height is going from top to bottom down the side. So the slant height is 15. And it says that we have a height of 9. The height is the perpendicular distance down through to the middle of the circle, in the base there. So that height is 9. So let's see if we can work out the surface area. So the surface area, make that an SA, surface area has one base, which is a circle, and it has a lateral area. Lateral area is the area of the sides. So the base is a circle, which is pi r squared, and the lateral area is pi r times the slant height, something you have to memorize. The lateral area is pi r times the slant height. And again, this is the slant height, this is the height, and this is the radius. So this height coming down here forms a right angle. So that means we have 15 here, we have 9 here, we have to work out this radius here. So c squared equals a squared plus b squared. It's the Pythagorean property on a right triangle. The hypotenuse c is 15, a is 9, and b, we'll call it r. So 15 squared is 225. 9 squared is 81. So 225 minus 81 is r squared. R squared is, subtract, you get 144. R is the square root of 144. So r is 12. So the radius is 12. So we have the radius of 12, and we have the slant height of 15. So we have pi, again 3.14, and the radius is 12, being squared. 3.14, radius is 12, and the slant height is 15. So when you take 3.14 and 12 squared first is 144 times 3.14, that'll give you 452.16 with a calculator. If you multiply 3.14 by 12 by 15, that'll give you 565.2 on your calculator. And if you add them up, you get 1,017.36. And we want to write to the nearest meter. So that's approximately, so the nearest meter, this is meters here, units. This is less than 5, so we leave it as 1,017. and it's square meters. Okay, let's do some more. Find the surface area of a sphere with the diameter of 3.6 feet to the nearest tenth of a square foot. Well, we have the surface area of a sphere is 4 pi r squared. So that's 4 pi is 3.14, and we need the radius, but we have a diameter. So if the diameter is 20, that means that the diameter is twice the radius, so 20 equals 2r, so divide by 2, so the radius must be 10. Oh, I said 20. Well, I don't know where I got 20 at. 20 came in my head then. The 3.16. Why I said 20 then must have been from the last problem. So 3.16, half of that is 1.8. I don't know where I got the 20, but my brain, again, is acting up. So the diameter is 3.16, and half of that is 1.8. So I have 1.8 being squared. Take a calculator and do 1.8 squared times 4 times 3.14, or go 4 times 3.14 times 1.8 times 1.8, and you'll get 40.6944. And again, we want it to the nearest tenth of a square foot, so it's approximately to the nearest tenth. This is the 10th place, so that's more than 5, so we add 1, so it's 40.7 square feet. Okay, one more. Number 4. Find the shortest distance from the equator to the North Pole. This is on the Earth. The radius of the Earth is approximately 6,400 kilometers. And we want to find the shortest distance on the Earth's surface. And we also want to make that shortest distance to the nearest kilometer. Well, let's draw a sphere and let's see what we have. The sphere is like a ball. And this is the center of the sphere. And so what we have is, what I'm now drawing is, that's the equator. That goes around the equator. Okay, so this is the North Pole is up here. And this is the South Pole down here. But we want to find the distance on the surface of the Earth from the equator, the shortest distance from the equator, which is right here, to the North Pole. Now, you can't go, that's the shortest distance, but that's going through the Earth. And if you want to travel, you have to travel on the outside. So if I want to get the shortest distance, this is the shortest distance that I have to travel to get to the North Pole. Again, unless I wish to go through the Earth. But we're talking about traveling, shortest distance from the equator to the North Pole on the Earth's surface. And on the Earth's surface, you're dealing with circumference. This is the circumference. So your circumference of the Earth is 2 pi r. But the distance we're traveling here, this is from here to here is only 90 degrees. So all the way around to here, from one end of the, so if you're here and you go to here, that's 180. So all the way around the Earth, if you travel around the surface of the Earth, is 360. But we're only moving 90. So that means the part that we're going to do is a part of the circumference. So the part of C is 90 out of 360 and times 2 pi r. So that means we have 90 out of 360 is 1/4. So we got 1/4 times 2 times 3.14 times the radius, 6,400 in kilometers. So 2 into 4 goes 2, and we can divide here. 2 into 6400 is 3200. So we have 3.14 times 3200, and that gives us 10,048. And that's automatically based on 3.14. But if you use pi instead of 3.14, you would have pi times 3200. And that would come out to be, if you use pi instead of 3.14, that would come out to be this number. And that would be 1,053 to the nearest kilometer. So using 3.14, you will get 10,048. If you use pi, that's on your calculator, and pi got many more places after in the decimal, you will get 10,053. So it depends on which one you use. Again, check with your teacher. So that's a review of the surface area of different geometric figures. And again, like all my videos, if you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. The content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.